Hey guys, welcome to lesson 611. We're starting chapter 6, which is all about triangle congruence. So for today, we're going to talk about the conditions or conjectures that are required in order for two figures to qualify as congruent. So far we've talked about triangle similarity, and if two shapes are similar, that means they are proportional to each other, right? One can be bigger or smaller than the other, so they don't have to be the same size, but they have to change in size by a certain scale factor or ratio, just all in proportion. So on the other hand, if two figures are congruent, that does mean they are absolutely identical figures. So they have to be identical, and what that means for them is that all of the parts have to be the exact same size. So all matching parts are the same size. All right, so we have 5 conjectures to talk about triangle congruence, and we used to talk about conjectures with regards to similarity, and for that one we just had 3 conjectures. So now there's a little bit more involved here. The first one is SSS, which is side, 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 which was also one of the similarity ones. You'll see a little bit of overlap here, but it's just that they mean something slightly different. So here, to qualify for side, side, side similarity, you need 3 pairs of equal sides. So as you can see in this picture, we have 1 pair here, each set with a matching tick marks. That qualifies for a pair of congruent sides. You know, sometimes I'll give you these kind of markings, and sometimes I'll give you matching numbers. So these 2 sides are congruent, these 2 sides are congruent, and so are these 2. So that qualifies us for side, side, side congruence. Side angle side, this time we have 2 pairs of equal sides and 1 pair of equal angles. Now remember from similarity that order is very, very important. If the things in the picture appear to be in a different order than what you are going for in your conjecture, it is not the same thing. So in SAS, you'll notice that it goes in the order of side, then angle, then side. So in this picture, we have the side, then the angle, then the other pair of sides, right? And it's consistent in both of them. It's still, in this one, goes side, angle, side. It's very important that the angles are sandwiched in between the 2 pairs of matching sides, because in SAS, the A is sandwiched by the 2 S's, right? So just remember, order is just as important here as it was in the similarity chapter. ASA, it's kind of like the inverted version of side angle side. This time the sides, like the matching side pair, is sandwiched by 2 matching angle pairs. Okay, so again, order is super important here. And what's really important is that in ASA and AAS, they both have the same letters, right? We have 2 A's and 1 S, 2 A's and 1 S. But the order is what differentiates them. So in ASA, it goes angle, then side, then angle. But in AAS, you can see that there's an angle, then comes the third part, which is the side. The side is absolutely not in between the 2 angles, because that would be the difference between AAS and ASA. So you have to watch out for those orders. And when you're looking for it, you just got to like rotate the triangle, right? You start somewhere and you just follow it around in either direction, and then the order in which things appear, that's what you would look for in your letters here for the conjecture. Okay, the last one is HL, hypotenuse leg. This one is only for right triangles, because only right triangles have a hypotenuse. All right, so in this picture, and I guess this picture is a little bit inaccurate, I'll fix it, the hypotenuse has to be matching. So these sides, the longest one, we know what a hypotenuse is from last semester. The hypotenuses have to match, and then one other leg, so one other side, has to be congruent or matching with the other triangle. As long as we have those 2, then we are good to call it congruent. And the reason for that is because right triangles, since they have this 90-degree angle, once these 2 particular sides match, the third one will have no choice but to match as well. All right, so let's try some practice problems. Our goal here is to take a look at these pictures and determine whether we think they are congruent, and if they are, we want to name the conjecture, and if they're not, we want to give some kind of explanation or reasoning as to why. So here we have some information, and we want to label the matching pieces. That's always helpful for me. So I see that there's a side that's 8 here, and there's one here as well, so that's a match. I see an 11 here, and I see an 11 here, so that's a match. And lastly, I also notice that there's a matching angle here of 70 degrees. So the first thing I want to check is if these things are in the same order. Like on this triangle, it did go like the 8 side, then the 70-degree angle, then the green side. Here, it did the same thing. The blue, the yellow, the green. So because they were consistent, that means that there is some hope for it to be congruent. So that's when we have to look into, okay, like which conjectures can we use? Well, there are 2 side pairs and 1 angle pair. So that tells us that we really only have one option, and that is SAS. And so we can say that these are congruent. Oops. These are congruent by SAS. All right. Next up, we have these 2 triangles. They are like conjoined here, so we'll still label it just like we did before. So we can see some matching tick marks. Remember what I said, sometimes there'll be numbers and sometimes there'll just be markings. So that side is congruent to this side. We have this side congruent to this side. And so at first you might think, okay, well, there's only 2 pairs of matching sides. But it's very important to note that if there is a shared side, like the 2 triangles are sharing some side, that side actually counts as a matching pair. And the reason for that is because if we were to separate, let's see, we'll draw this. If we were to separate these 2 triangles, this is going to be kind of rough looking, but here's one triangle, and then here's the other triangle. They're not the best, but they could be worse. All right, so if we were to separate them and say, okay, here's one, here's the other, right? Now we know that they shared this 3rd side, and so that side has to match, right? These 2 we know will be the same length because they used to be completely joined together. So that means that we can consider that to be the 3rd pair of congruent sides. So we don't have too many options here. We found 3 pairs of equal sides, so that means we have SSS congruence. All right. Next up. So let's start this one the same way. We will go ahead and start matching. Get my colors going here. All right, so we got a 12. We have a 12 here too. We have 16. We have a 16 here as well, so, you know, that's a good sign. And lastly, we have this angle. So here's the thing we have to look for. After you look at this first picture, you might be inclined to say, oh, well, we got a side, an angle, and a side, so this should be SAS. But if you look at this triangle and look at the order, you'll notice that something is off. In here, where it goes blue, yellow, red, here it goes blue, red, yellow, right? The angle is actually not in between the 2 sides like it is here. It's after the 2 sides. And because there's inconsistency with the location of these matching parts, we cannot conclude that they are congruent. There has to be consistency of location. That's why order is so important. Okay, so if that yellow angle was like right here, then we would have been good to go. But it's not, so we can't call them congruent. All right, so for this next one, we have a pretty basic one here. We got a 40-degree angle that matches. We've got a 70-degree angle that matches next. And lastly, we have this whole side that matches. They're both 3. Yikes. So when you start at any one of these parts, I'll start at this red angle. We know that these 2 angles match. The next up is this purple angle, the 70. And then next up is the green, the side that's 3 centimeters. So they're both pretty consistent. And it goes angle, angle, side as I rotate around the triangle. So angle, angle, side is one of our conjectures. Therefore, we can go ahead and say that these are congruent by angle, angle, side. All right. Now for this one, again, let's go ahead and match parts. We've got a side here that matches. These 2 tick marks indicate that they're matching. We've got this angle pair. And we have also got this angle pair. So you look at the order and you're thinking, okay, red, blue, green, green, at least they're consistent. And we go angle, then a side, then an angle. Is that one of our conjectures? Well, yes it is. ASA is valid. So we will say that this has angle, side, angle, congruence. All right, there is one thing I want to mention. I forgot to do it in this last problem that I'm gonna go back and do it now. If we wanted to write a congruence statement for these triangles, we did that in similarity, so I wanna show you how it's done here. It's the same exact thing, in fact. So if I were to go ahead and name this first triangle, we can call it angle LMN. Why not? And I wanted to say, okay, LMN is congruent to this triangle. When I name this triangle now, I have to follow the same matching order. So L matches with X on this triangle, so I got to start with X in the statement here. M matches with Y on this triangle, so Y is next. And then N matches with Z, so Z is going to be next. So this is how you would write a congruence statement. I know you have to do that on the open math problems. So, all right, and then the last thing that I do want to point out is that SSA, this is a huge thing. SSA or ASS is not a congruence conjecture. If you ever find some triangles that look like they have matching pieces that satisfy ASS or SSA, it doesn't matter. Those are invalid credentials. You can't use this to declare congruence. So that will always be there to trick you. All right, give the open math problems a try if you haven't already, and let me know if you have any questions.